So welcome back to Multivariable Calculus course and in the topic of three-dimensional space, today we are going to talk about equations of line in 3D. You are already familiar with this concept of equation of line in 2D. Now we will generalize it to 3D, right? So as you know that in order to find the equation of line, we need only two things, one point lying on that line and one slope of that line. So we get the equation of line as y equals mx plus c. That is going to be the equation of our line, right? Where m is the gradient or slope and c is the y-intercept for 2D. But now we have to learn how to find the equation of line in 3D. So this time we also need this gradient or the slope thing, but in 2D it is different actually. Here what we need is we need one point lying on that line. So let's call this point is a given point, call it P. Okay, so you can also call it R naught, having the uh, coordinates of that point as say x naught, y naught, and z naught. Okay, now we need a vector which is parallel to this line. Okay, vector parallel to this line can be in any direction like this or and of any magnitude, but our vector must be parallel to the given line. Once you have the vector parallel to the given line, you can always find the equation of that line. For example, let's consider this time a vector which is parallel to this line is say v vector. Okay, and having its components or the direction ratios at let's say a, b, c. Hmm? So we have point and we have direction vector, parallel vector or vector parallel to our line, and hence equation of line can be, let's say there is another point, say general point R, and its coordinates are say x, y, and z. General point lying on that line, it means it is the moving point on that line. So I can say this R vector or R minus R naught, right? Because R is general point, R naught is what? Given point. So R minus R naught, this vector is going to be equal to some scalar multiple of that V vector. Okay, that's it. What that means? It means this simply RP or PR. Okay, this PR is going to be some scalar multiple of V. That's it. So R minus R naught is equals to TB. So from here I can say R is equals to R naught plus T times V. This is vector form. Okay. R naught is any point lying on that line. T can be any real number. For any value of T, you will get different points lying on that line. And V is parallel vector. Okay. So now vector form, after that we can convert it in parametric and symmetric form also. How? See, R vector is what? R is our x, y, z. So this is equals to that R naught, which is x naught, y naught, z naught plus t times this a, b, c. Okay. So now we can compare the x coordinates, y coordinate and z coordinate on both the sides. So from here x is equal to what? X naught plus t times a. So x equals to x naught plus ta. Similarly, y value is y naught plus tb and z value is z naught plus tc. This form is called parametric form where t is the parameter. Okay, so here we converted our vector form into parametric form. There is one more form called symmetric form or Cartesian form. What is that? See, from these you can, what you can do is you can solve for t. Okay, so from here what is t? First equation says t is x minus x naught divided by a. Similarly from here t is y minus y naught by b, and for z part we have t equals z minus z naught over c. All are t, we can equate these, and hence we will get x minus x naught over a equals y minus y naught over b equals z minus z naught over c. This is the equation of the line in the symmetric or Cartesian form. This form is very important. Okay, so these three forms we covered so far. First one is vector form, second is this parametric form, and third is this symmetric form. If you have to find the equation of line, you need two things only: one, point lying on that line, and direction vector. If the equation of line is already given to you, you can always find the point lying on that line, one point, and the direction vector. For example, in the question, okay, if they says that there is a line having the equation x minus 3 over 5 equals z plus 6 over 2 and y plus 6 over 2, let's say y plus 6 over 2 and z minus 5 over 8 or minus 8. Let's say we have this equation of line. So from here, what can you say? You can say your direction vector or any vector parallel to this line is what? This 5, 2 and minus 8, the denominator part. And any point lying on that line, okay, can be what? From the top. It is x minus 3. So x minus x naught was there. So it is 3. Y plus 6, I can write it as y minus of minus 6. So basically, y naught value is minus 6 and 5 is the z value. So if the equation of line is given, we can find one point lying on that line and the direction vector. Okay, and if direction vector and point are known, we can find the equation of line. One more thing. If you are given 2 points lying on that line and you have to find the equation of that line passing through these 2 points. So for that case, let's say this is x1, y1 and z1. Okay. And the second point is x2, y2 and z2. Now you have to find the equation of that line passing through these 2 points. So R naught you can choose as either x1, y1, z1 or x2, y2, z2. Both works same. But for the direction vector, you have to form a vector which is parallel to this line. So what you can do is, this is P, let's say this is Q. So you can say your V vector is actually PQ vector. Simple. Position vector of Q minus position vector of P means x2 minus x1, y2 minus y1, z2 minus z1. These will be the direction ratios. Okay, I'll show you with an example. If you find any difficulty so far, please feel free to connect with me. You can contact me on this WhatsApp number or Telegram channel. And if you need one-on-one sessions or group sessions, okay, you can contact me on this number. Feel free to connect with us. Okay? And if you want any other information, then also you can contact us. Next one. So as I said, let's solve a question on that one. This is the vector form, parametric form, and symmetric form I already discussed. And solve this one, write down the equation of the line passing through the points 2, 1, 3 and 1, 4, minus 3. So what we have here? We have 2 points lying on a line. Okay, so if 2 points lying on a line are known to us, in order to find the equation of the line, what we needed? One point and one direction. So here it is 1, 4 and minus 3 is one of the point. Let's call it P. And second point is, let's say here, Q having its coordinates as 2, minus 1, 3. Okay. Now, in order to find the V vector, you can choose P minus Q, Q minus P, that doesn't affect. Okay, so this time I'm taking PQ. Okay, so my V vector will be calculated by position vectors of Q minus position vectors of P. So OQ minus OP. What is that? It is going to be Q coordinate, which is 2 minus 1. Then Y coordinates are minus 1 minus 4 and Z coordinates are 3 minus minus 3 means 3 plus 3. This is your V vector. Hence, what is V vector? It is 1 minus 5, 6. Now, equation of the line, we have to find all the three forms. Okay. So I can say, what is my given point, by the way? Either you can choose 2 minus 1, 3 or you can choose 1, 4, 3. Okay, both are correct. So let's write the first form, vector form, which is going to be r vector is equals to r naught. So I will write it as what is r? 2, r naught is 2 minus 1, 3. So let's take this one, 2 minus 1, 3 plus T times t can be any real number. T times this 1 minus 5, 6. This is the vector form of the line. Okay. So if you want, you can also write the same as r vector is equals to 2 plus t minus 1 minus 5t and 3 plus 6t. Okay. That is the first form. Now the second form. Corresponding to this, I can find the parametric form. What is that? It is going to be, its x value is going to be what? 2 plus t. What is y value? Compare the y coefficient, y coordinates for this. So what is that? Y is going to be equal to minus 1 minus 5t, and for z part, it is going to be 3 plus 6t. This is the parametric form. Now for the symmetric form. It's simple. Either find the t values from here, okay, but if you don't want to calculate t for this symmetric form first or parametric form first, directly you can find the symmetric form. How? It is x minus x naught means 2 divided by 1, okay, direction vector. Y minus minus 1 means y plus 1 divided by minus 5 is equals to z minus 3 divided by 6. That is the symmetric form. Okay, but this time I considered my point as what? 2 minus 1 and 3. Okay, I got all these answers corresponding to that only. But what if I choose my point as 1, 4 and minus 3? Then I will get another representation for the same line. Okay, r vector is going to be equal to what? This time I have to choose 1, 4 and minus 3. So 1, 4, minus 3 plus t, or let's use some other number, say s. Okay, you can also take t, that's fine. 1, minus 5 and 6. So both are same. This and this, both are correct. Okay, corresponding to this, you will get y is x equals to 1 plus s, y equals to 4 minus 5s, and z is equals to minus 3 plus 6s. Okay, that is also correct. Either you write it that one or this one, both are okay. Okay, third one, you can also write Cartesian form or the symmetric form with that point 1, 4 minus 3 in this way. X, this direction vector stays same. So I'll write minus 5 is equals to that z something divided by 6. So I'll write the point. What is that? 1, 4 and minus 3. So minus minus will become plus this. All are correct. Okay, and you can choose any other direction also, any multiple of that. For example, here I'm using 1 minus 5, 6. You can multiply it with any other number. Say you are multiplying it with 2. So 2 minus 10 and 12 are also correct. So overall the thing is, if the one point and direction vector is known, you can find the equation of line. Okay, next one. It says determine if the line that passes through this point, given point is there, and uh, parallel to this line given by this, it is parametric form. So here what we have actually, we have parametric form of another line, and our line is parallel to this line, right? Our line is going to be parallel to this line. So we have one point also lying on our required line. So let's say this is our required line, and we know one point lying on this line. What is that? 0, minus 3 and 8. In order to find the equation of this line, what I need is, I need a vector, direction vector. But I don't have directly that direction vector, but I do have another line which is parallel to my line over here. Okay, and the equation of this line is x equals 10 plus 3t, y equals 12t, and z equals minus 3 minus t. This is the line, right? So using this parametric form of the line, first I need its direction vector. So what is the direction vector? Either you can convert it in Cartesian or that symmetric form. Okay. So denominator parts will give you the direction vector. So here, if I write it like this, x minus 10 over 3 equals y minus 0 over 12. I'm just finding the values of t and equating them. Z plus 3 over minus 1. Okay. So from here, what can I say? My direction vector is going to be 3, 12, and minus 1. But the thing is, this line is parallel to our required line. So both are parallel means they must have same direction vectors. So here we have same, we can choose the same direction vector for our line also. Let's find the equation of line first. So directly I will use this Cartesian form or the symmetric form. What is that? X minus 0 over 3 is equals to y minus minus 3 means y plus 3 over 12 is equals to z minus 8 over minus 1. Okay, I can also convert it in the symmetric form, parametric form, sorry, by from this symmetric to parametric. It is symmetric. Now I'm converting it into parametric. What is parametric form? X equals to this 3t, y is equals to 12t minus 3, and z is equals to minus t plus 8. So from here, according to this question, then we have to check whether our required line passes through xz plane or not. What is the meaning of xz plane? Xz plane simply means that y value is 0 over there. Okay, so it means the y part must be 0 always. So let's find that value of t for which this happens. Okay, so we will get a particular value of t. So 0 is equals to 12t minus 3. That gives me t equals 3 by 12, or we can say t equals 1/4. So now we got t equals to 1/4. This is our required value of t. Means for this particular value of t, our line will pass through the xz plane. So let's find the x and z coordinate also for that point. So use this t back to this as well as this and solve for x. First, what is x? 3 by 4 simply. Now, what is z from here? Z is minus 1 by 4 plus 8. So you can simplify it by writing it 31 by 4. Hence, what are the coordinates of that required point? The final answer, it says if it cuts. Okay, yeah. First thing is, yes, we got that point. Means yes, our line passes through xz plane. Now, if it does gives the coordinate of the point. So what are the coordinates of that point? Means we have x value as 3/4, y value obviously 0, and z value is 31 by 4. So this is our required point. Okay. So that was all about the equation of line. I tried to explain this, all the types of forms of equation of line. Okay, vector form, symmetric form, parametric form, how to convert from one to another, how to find the point and the direction vector if the equation of line is given to you. Okay, so and we also solved some questions on them. Why do we need it? Later we are going to need this equation of line portion for solving these line integral, surface integral, and multiple integrals. Okay, and also for finding the tangent, normal line, tangent plane, normal plane, all these. Okay, so we are done for today, and in the next session, I will continue with this equation of plane part. So till now, keep watching, keep learning. Thank you for watching this session, and you can connect with us using this WhatsApp number. If you need any help, feel free to connect with me. Thank you.